Mastering API Gateway Implementation. Someone in this organization is accountable for preventing API downtime. Who within the organization is responsible for implementing load balancing, auto scaling, and distributing traffic across multiple availability zones to ensure high availability and scalability of the API gateway, thereby minimizing downtime and guaranteeing seamless access to the API. In the context of API gateway implementation, operational excellence is pivotal in ensuring the high availability and scalability of the API gateway. To achieve this, it is essential to implement load balancing, auto scaling, and traffic distribution across multiple availability zones. This can be achieved through a combination of people, processes, and technology. To begin with, the organization's DevOps team, in collaboration with the cloud infrastructure team, is responsible for designing and implementing the load balancing and auto scaling strategy for the API gateway. This team is responsible for ensuring that the API gateway is highly available, scalable, and fault-tolerant. The first step is to design a load balancing strategy that distributes incoming traffic across multiple instances of the API gateway. This can be achieved using Elastic Load Balancer, ELB, or Amazon Route 53. The load balancer should be configured to detect instance failures and automatically reroute traffic to healthy instances. This ensures that API requests are not lost in the event of an instance failure. Once the load balancing strategy is in place, the next step is to implement auto scaling. This involves configuring the API gateway to automatically add or remove instances based on traffic demand. This can be achieved using Amazon CloudWatch and AWS Auto Scaling. CloudWatch monitors the API gateway's performance metrics, such as CPU utilization and request latency, and triggers auto-scaling events when these metrics exceed or fall below predefined thresholds. Auto-scaling ensures that the API gateway has the necessary capacity to handle changes in traffic demand. For example, during peak hours, the API gateway can scale up to handle increased traffic, and during off-peak hours, it can scale down to reduce costs. In addition to load balancing and auto-scaling, it is essential to distribute traffic across multiple availability zones. This ensures that the API gateway is available even in the event of an availability zone outage. This can be achieved using Amazon Route 53, which provides a highly available and scalable DNS service. Route 53 can be configured to route traffic to multiple availability zones using latency-based routing, geolocation routing, or weighted routing. This ensures that API requests are routed to the nearest availability zone, reducing latency and improving performance. Furthermore, the organization should implement monitoring and logging to detect and respond to outages and performance issues. This can be achieved using Amazon CloudWatch, AWS X-Ray, and AWS CloudTrail. These services provide real-time visibility into the API gateway's performance, latency, and errors, enabling the DevOps team to identify and resolve issues quickly. In terms of process, the organization should establish a set of standard operating procedures, SOPs, for API gateway maintenance, deployment, and troubleshooting. These SOPs should be documented and communicated to all stakeholders, including developers, DevOps engineers, and support teams. The SOPs should cover aspects such as code deployment, instance management, monitoring, and troubleshooting. This ensures that the API gateway is consistently managed and maintained, reducing the risk of human error and downtime. Finally, the organization should establish a culture of continuous improvement and learning. This involves regularly reviewing and refining the API gateway's architecture, load balancing, auto-scaling, and monitoring strategy to ensure that it meets changing business requirements. In conclusion, ensuring the high availability and scalability of the API gateway requires a combination of people, processes, and technology. The DevOps team, in collaboration with the cloud infrastructure team, should design and implement a load balancing and auto scaling strategy, distribute traffic across multiple availability zones, implement monitoring and logging, and establish SOPs for API gateway maintenance, deployment, and troubleshooting. By following this approach, the organization can minimize downtime and guarantee seamless access to the API.